Okay. So let me just check and make sure I've got audio real quick. Okay. Got audio, okay. All right, so this live streaming thing is something I've never attempted to do before, so I figured I'd give it a shot. And what we're going to tackle today is we are going to begin the development process of a new game engine using C++. Right now I'm going to be using Visual Studio. I might port this use something else later on, but since I'm most comfortable with Visual Studio, that's what I'm going to roll with. And what we're going to do is we're going to create a game engine with a Vulkan renderer. And this is going to be a bit of a long process because not only is it a bit of a lengthy process to get Vulkan set up, but there's also a lot of things that I want to do to the engine long before we actually render anything to the screen. So I do want to point out that this is not for the faint of heart. This is for the people that definitely want to go into hardcore engine development. This is not going to be one of those quick tutorials where we get something up on the screen in 5 minutes. Like I said, we're probably not even going to get much up on the screen, if anything, in this streaming session. So what we're going to do is create this from the ground up. I don't even have a solution created yet. All I've done is create a GitHub repository and clone it. And the only thing that it contains is a readme and a gitignore, which is actually blank. So I've gone ahead and cloned this on my local machine, and I'm going to go ahead and get this set up. So I'm actually going to create a new project, and I want an empty project for Windows. And I'm going to create it. Wrong box. I'm going to create it in this regen folder that I've created. That's what I'm calling the engine for now. I might rename it later, but for now that's the name I'm going to roll with. And I'm going to call the solution regen and the project regen.engine for reasons that'll become apparent later. And let's go ahead and create. Takes Visual Studio a minute or two to actually get everything set up. Okay, so the first thing I'm going to do is actually save all and close this, because the way that Visual Studio sets this up by default isn't exactly what I want, because it creates sort of another subfolder and then puts the solution file here and the engine project within that. And I actually want to move these things up a level. So what I'm going to do is I'm just going to rename this real quick to, I don't know, something temporary. I'll just call it X for now. And I'm going to cut these 3 folders and move them up a level and delete X. And in my gitignore, I'm actually going to open that with Notepad++ really quickly. And I'm just going to ignore a couple things right off the bat. First, we want to ignore our .vs folder. I'm also going to be creating a folder called build, so I want to ignore that. And a folder called obj. I want to ignore that. And I think that's about it for right now. So I'm going to save that and close it. And pop back open the solution. Okay, so the next thing I'm going to do is a little bit of preparation here as far as the configuration of the solution. One thing that Visual Studio does is it always creates these projects with 64 and 32-bit support, and I'm actually not going to be supporting 32-bit here. I don't really see the point in this day and age, so I'm actually going to go ahead and remove that. So let me edit this list, move x86, yes, yes, okay, actually switch to x64. Does that not remove it? Okay, let's try that one more time. Close. Okay, so now all we should have, the solution level is actually 64. You can see the project here still has Win32, so we need to declare that next. So if I select the project, configuration manager, and edit. Oh, it looks like 32-bit is actually gone from there. I'm not sure why that was showing. Oh, I guess I need to remove it from here. Right. Remove that. Okay, so now we should only have 64-bit. Perfect. Okay. So the next thing that I want to point out is we need a couple of things installed. So one of those things is the Vulkan SDK. So we search for this. We can find it here at LunarG, and LunarG has the official Vulkan SDK, and we could download that for Windows. And I'm going to be using 1.2.131.2 because it's the newest released version of Vulkan. I don't really see a point in using the older version since everything should be compatible. We should be good to go ahead and use 1.2, so that's what I'm going to use. I've actually already got this installed, so actually if I go to here under Vulkan SDK, I actually have multiple versions of the SDK installed. When you guys download this and install it, you guys will probably only have this version here. So obviously you'll want to pick the correct one for your platform and architecture. In this case, I would have downloaded this top one here with the installer. So I've already done that, so obviously I don't need to repeat that step. Okay. So back in my regen folder, I need to grab a couple more things and download them. But first, I'm going to create a new folder, and I'm going to call this external. And this is where I'm actually going to place all of the various libraries that I'm going to be downloading and using. So there are lots of different ways to set this up. You can use different package managers, but I don't want to do all that. This is way quicker, in my opinion, to just set it up this way. So that's what I'm going to roll with. So under this, I'm going to create a new folder for include and a new folder for lib. And any libraries that we're going to be linking against will be in lib, and then any include header files will actually be in this include folder. Okay, so now that we have our SDK here, the next thing I'm going to go ahead and do is grab GLFW. This is to create a window in a OS independent way. So I'm going to try and keep this, I'm going to try and keep as much platform-specific code as I can out of this for now. And this is one quick way to do that. If you guys want to go through the process of creating a Win32 window or an X11 window or whatever window system it is you're using, there are plenty of tutorials out there to show you how to do that. I'm going to skip over that for now for the sake of time and just use GLFW. Okay, so we're actually going to need two things from this. We're going to need the binaries for, in this case, 64-bit Windows. So I'm just going to open that. And if we go in here, we are presented with the include, which we're going to need. Just has two header files in it. And we also have the lib VC 2019, which is the version of Visual Studio I'm using. So I'm going to want to grab those. So I will copy those first and place them in the lib folder. And then I'm going to copy the GLFW from the include folder here and place it into the include folder in our external library. And these things will actually be checked in along with everything else in the repository so that It's really easy to clone this and just be able to build it without having to download all the dependencies. I may switch to using Git submodules at some point, but for right now, this just makes things very convenient, in my opinion. So we should be done with that. That should be all that we need at the moment to be downloaded. Now we just need to set up our project to actually link to these things. So in the engine configuration, I need to do a couple more things. So first off, the output directory, I actually want to change that because right now it's actually, this is going to output to the solution directory, and then platform, which is going to be x86, and then the configuration, which is going to either be debug or release. I don't want all of that pathing. I just want it to go to solution directory build. And that is going to output my executable to a build folder that is in the solution directory. And that was, if you recall, the one of the directories that I ignored in here in the git ignore. So that way, none of our built binaries actually wind up getting checked in. The intermediate directory I'm going to change as well. I'm going to use solution directory, if I can type. And then I'm going to use the obj. And then I'm going to use the project name. Oops, I need... There we go. And what that's going to do is that's going to output all of our intermediate files that are used before the linking process to the object folder, but then create another subfolder for the actual project that we're building, because eventually we're going to have multiple projects in here for different parts of the engine and eventually the application. And so we don't want there to be potential collisions between those intermediate files. So the best way around that is to just split one off into project name for each one of these. So we're actually going to be using that across the board. One thing I do want to mention is I do have all configurations selected here. It may default to debug or release. These are settings I want to use in both cases. And then anything that is specific to debug or specific to release, I'll go ahead and add afterwards. But for now, I want to be affecting all configurations so I don't have to go through and retype this all again. Okay, so let's see. I also need... So under include directories, I actually need to add another entry to this. So if I add here, I want solution directory. And I want to go ahead and use include. And I don't remember if I need a trailing slash after that or not, but this should use, oh, I'm sorry, that needs to be external include. And that will allow us to use the files that we added to our include. So let's go ahead and test that out real quick just to make sure that I got that right. I'm going to add a new item. Let's add main.cpp. Cool. And if I include GLFW, yep, it's there. Okay, so that is done correctly. There is one more thing I need to add to that though. So if I go to my PowerShell and there should be a, I thought there was a Vulkan I guess there's not an environment variable. I could have swore that there was. All right, for now, I'll just use the hard-coded path. So we also need to make sure that we include our Vulkan SDK includes as well. So we actually need to add this path. And I know I'm hard-coding this for now. I'm going to change this up later. But for now, for the sake of getting things set up, I'm just going to go ahead and put it this way. Cool. Like, I'm not sure if I need the trailing slash there. I don't think I do. Okay, so now we have our includes for our Vulkan SDK and any external libraries that we're going to be using. And our linker needs a couple of additions as well. So we have additional library directories here. We want to go ahead and add to this as well. And for this, we're going to use the Vulkan SDK, but instead of the include, we want the lib. Lib32 is if you're building a 32-bit application, but we're not doing that, so I'm just going to add lib there. And I also need to add solution directory, external lib. Okay. Apply that. Let's just make sure this builds real quick. Should. Actually, it's probably not going to because we don't have main. Right, so create our entry point here, main, and we're going to have int argc, and then argv, and return 0. Okay. So that should work. I'm going to debug this real quick. And we get our window that pops up that says press any key to continue. So I think we're good. Let me just switch over here to the chat window. Cool. Let me pop this out actually. Cool. So, hey guys, welcome. Yes, it's going to be a 3D engine. It's going to be a bit before we get to that point, but yeah, it is going to be a 3D engine. So it's going to have full 3D support. I might wind up adding a 2D API later, which really is just an overlay of 3D because everything as far as the GPU is considered 3D anyways. But yeah, it is going to be 3D. Let's see. Will I delete the stream later? No, I will not. I'm going to leave this posted on my channel. Let's see. So yeah, which encoder am I using? I'm using OBS, and the bitrate I think was YouTube's recommended. What was it? 4500, I think. Yeah, I think it was 4500. Yeah, video bitrate 4500. Cool. So I'm assuming you guys can hear me okay and whatnot and see all the code. I'll just assume yes. Cool. So I'm going to move on. So let me just check my notes here. Okay, so there's a couple things that I like to get out of the way pretty early on. I like to create some type defs to sort of simplify some things for me. So I'm going to add a new item. Call this types. And so the way that I like to set this up is I like to create all the integer types and type def them away so that I don't have to do as much typing later on. And the reason for this is I am going to have to use all different sizes and signs of integer types. So I really don't want to have to do this more than once. So I use this for unsigned integers. I use this u and then the bit width of the type. So an unsigned long is u64, an unsigned int is u32, an unsigned short is a U16, and then an unsigned character is a U8. And then I can also just reuse these things for the signed type. So change that up real quick to I64, 32, 16, 8, etc. And then I like to do the same thing for float. So type def float, and that's going to be, I'm going to call that F32, and then type def double, I'm going to call that F64. I'm probably not going to use doubles all that much, but in case I do, it makes things a little bit easier to manage so that I don't have to type out all this verbose language all over the place. So I like to do that. And then I also like to define a few things that help me out throughout my code base. So I'm actually going to create a new header. All this defines. And I do a little bit of OS detection here because of some of the things that I'm going to be using later. So I think I'm going to go ahead and get all this worked out now versus waiting till later to do it, just to get some of these things out of the way. So if we are Win32 or Win64, those things are provided to us automatically by the compiler. Then we're going to define, and we're going to call this platform Windows. Even though we're not supporting Win32, technically speaking, I want to go ahead and include that just in case. And then otherwise, we want to check if __ Linux __, then we're going to define platform Linux, and then else if Apple, oops, and then I'm going to define platform, we'll call it Mac. And then if we get past all these things and we have not found anything, we're actually going to throw an error and say unable to determine platform. And then endif and another endif to round that out. That should be good. Okay. And that's about the extent of the platform detection code that I'm going to do for right now. But I am pretty much immediately going to use it. So the next thing I want to get put in here is if we are on Windows, we want to define a couple of things. So first we want to define what I'm calling force inline, which is sort of a it's an override to tell the compiler to force something to be inline. And this force inline is something that's I believe this one is specific to Windows. There are other ones for the other platforms. I'm not going to fill those out right now, but I need to get them in here at least for Windows. So if you guys happen to know what those are for the other platforms, let me know, and I can always add them. And then I also want force no inline. And again, I'm not really going to be using this right off the bat, but it is something that I'm going to be using somewhat soon. I don't want to forget to do it. So, okay, so that's basically to force something to not be inline, and to tell the compiler, hey, no matter what your optimizations are, don't inline this no matter what. Cool. So The next thing I'm going to do is I'm going to create something that allows us to have an API for DLL imports and exports. And this is a bit of a Windows specific thing. And we're going to use this later on when we move the entry point of our application to our library instead of our executable. But I want to get this filled out right now. So I'm going to call this regen API. So let's see. Actually, no. I'm going to call this regen build lib, and I'll define that in a second. And if it's defined, then I want to also define regen API as decal spec DLL export. And then if not, else I want to define it as DLL import. Cool. And then let's see if for Windows. Let's see. So okay, I probably ought to include at least a stub for the other platforms as well. For Linux or platform Mac. Define force inline as just inline. And then I'm going to put a to-do here. Define regen API for these platforms. Just so we can kind of move on. Okay. Let me just check chat quick. Can I zoom a little bit? Yes, I can definitely zoom a little. Are DirectX12 and Vulcan similar in any ways? Yes, they're actually similar in a lot of ways. I am not through and through familiar with DirectX12. That's one of the things that I want to tackle after I get really comfortable with Vulkan. But from my understanding, they're very, very similar in terms of how they're actually set up and how they're actually how their APIs are situated. They're both very explicit APIs, from my understanding. I know definitely Vulkan is, and from my understanding, DirectX12 is as well. Probably no AMD GPUs work better on Vulkan. To be honest, I don't know whether AMD GPUs work better on Vulkan versus DirectX. I couldn't really answer that. I haven't actually looked that up, so I'm not sure about that. All right, so let me zoom this in. Is that a little bit better? Hopefully you guys can see that a little bit better. Okay. So, let's see. The next thing that I want to do is, why is this bleating at me here? Directive is missing. Why do I have an extra? I'm not sure why I had an extra one there. Okay, let me get rid of that. So the next thing I want to do is create a quick utility method for assertions. And this is actually something that I picked up from this book. Let me just make sure that you guys can actually see what I'm holding up here. So this is Game Engine Architecture. It's by Jason Gregory. Highly recommend this book. And one of the things that that he mentioned in there is creating a assertion, couple of assertion macros. Ones that so you have one basically that stays in your release build and is always there, and then you have another one that's in your debug build that gets basically, it doesn't do anything in your release build. And I've kind of adopted that, and I really like the way that that works. So I'm going to go ahead and add that here. Cool. So let's go ahead and do that. Assertions. So first thing I'm going to have to do here, I'm going to need IOStream. Let me actually wrap this in a define so that we can turn it on and off. If def assertions enabled, because we may want to actually shut all this off at some point. So, oops, caps. Let me go ahead and wrap this in that, and for now, I'll actually just define it here. Okay, so if assertions are enabled, then we need to basically set up what I'm going to call a debug break. This is, again, another thing that's suggested by that book. So if we are actually, if we are using the MSC compiler, then we can actually use intrin.h, which gives us access to intrinsics, and we can define debug break and call __ debug break. Otherwise, for now, I'm just going to use I actually don't know if this is going to work in 64-bit. I think this only might work in 32-bit. I'll have to look this up at some point. But basically, this is an inline assembly code to cause a break in the application. So if we're debugging and we call this debug break macro on the other platforms, or I should say on the other compilers that aren't Visual Studio's compiler, then we will call this inline assembler. Otherwise, for now, we're going to be using this debug break that's provided to us by Microsoft. I need an ndef for assertions old. Okay. Okay. So now I'm going to create the assertions themselves. And these are really simple. Visual Studio keeps trying to format for me. Okay, so expression and whenever you're declaring a macro, you have to make sure to include these backslashes at the end of the line. Otherwise, the define becomes invalid. So you're basically saying, I want to include the next line as part of this definition that I'm creating. So if we're in a situation where our expression that we pass through is false, it evaluates to false, and that could be maybe it's a null pointer, or it could be some condition that isn't met that we're expecting to have met. We want to go ahead and call debug break. And one other thing that we're going to need is we're also going to need a a way to actually report this, so that in the console we can actually see what the assertion is, rather. So I'm going to create a new force inline void. I'll call this report assertion failure. It'll take in a string expression. That'll be the string representation of the expression, rather. A message and a file. Whoops, can't type today. And a integer line number. Okay, and this will allow us a quick and easy way to say, hey, this assertion has failed. So I'm simply just going to output expression. I guess I'll say message. Put a single quote there. We'll wrap the message in single quotes. Message. And then in file, line, new line. Think waiting function. It is a function. I'm going to move this down here real quick, actually. Something. Not sure why this is complaining. Okay, I'll come back to that. What I wanted to add is before we debug break, we're going to want to report assertion failure. We're going to want to pass the expression and saying pound expr. So this basically gives us a string representation of what was passed here, which is what we want. The message passed through in this case is going to be 0. The file, I'm going to use the __ file macro and the __ line macro. And that should be good there. Really don't understand why this is erroring. I guess I'll come back to it. Okay, so I also want a copy of this assertion. We're going to call it assert _ message so that we can provide a custom message. And the only difference here is that. Okay, so one more thing that I want to do is the debug assertion. So if defined _debug, which is automatically given to us by the project settings, then we want to go ahead and define this, which is just a copy of assert up above, except we're going to add debug to it, and then endif. Okay, let's see here. One more thing we're going to need to do is if check my notes here. All right, so the other thing that we're going to want to do is the other half of this that I mentioned, where if we have a setup where we don't want assertions to be included, we need a way to actually shut those off. So I'm going to add an else to this, and I'm going to grab this and just paste it in there like that, where it'll still be defined, so it'll still compile in our code, but it won't actually do anything. And then, let's see. Or assertions are enabled. Oh, that's why this is complaining. This should be after this end if. Okay. So, what we're looking at here is our if def for assertions enabled. So if we actually shut all assertions off, then we want to redefine these things here to basically do nothing. So I'm actually just going to copy these guys and paste them and just remove their definitions. And put this comment after all these guys. Cool. That should be it. This is still bleating. I understand why. Let's build it. Back in main, I want to include types and include defines. Let's build that. Builds fine, so I'm not really sure why this is being picked up as an error, because it seems to build just fine. That's weird. I've never had that issue pop up anywhere else I've used this type of assertion. All right, I'm just going to move on. So that's pretty much it as far as assertions go. They're pretty straightforward, but it's something that I wanted to go ahead and set up now so that I don't have to worry about it later. The last thing that I want to set up before we jump into the window creation, as it were, was I want to add a logger. It's going to be a simple logger for now, but it's going to allow us to not have to basically put stdio all over the place and have these weird, ugly streams all over the place just to output strings to the console. I want to make that clean from the get-go so that we don't have to fuss around with that. So this is actually going to be the first class we're going to create. So I'm going to create all of our classes under namespace regen for now until we obviously rename the engine. And the class is going to be called logger. And all these methods are going to be public. And we want them to be static as well. So static void, we're going to create a trace. And trace is going to take in a message and then an ellipsis, which basically says it's a variable number of arguments. It's similar to the way that printf works, for example. So we're going to use that very similar functionality for our logger, so that way we can sort of format strings and do anything else that we may need to do inline without having to make a bunch of gross calls to sprintf and stuff like that. So I'm basically going to duplicate this a few times, and I'm going to create a couple of different versions of this. So I'm going to create a log, I'm going to create a warn, I'm going to create an error, and a fatal. And the difference between error and fatal is basically errors are something that affects the way that the application runs, but it shouldn't be terminal. Versus fatal, which is actually going to crash the application. Anytime that we encounter some sort of fatal error, like not being able to create a Vulkan instance, for example, we're going to use fatal. So that way we can be absolutely sure that the application is not going to proceed with any sort of undefined behavior. Cool. So let's get on with adding the implementation of these. So I'm just going to add new item. I'm going to call this logger CPP. I'm going to include logger.h. Throw all these under namespace regen as before. And then we'll obviously need to put the logger prefix on there. Remove the static keyword all the way down. Should have done that first, actually. Okay, cool. So these are all basically going to do the same thing, except they're going to prefix our output with a log level, and eventually we're going to set this up to be able to only output certain log levels. So we could chop these off at log and not output trace, for example. I'm not going to set all that up right now. That'll be something that I can add easily later on, if and when it's needed. So I guess the next thing I'll need to do, actually, I need another private static method here that I'm just going to declare in logger CPP. So this is going to be a static, I'm going to call this write log. And this is what's actually going to handle writing things out to the console. So it's going to take a const character string, and this is going to be the prepend. And then we're going to take another string, which is the message. And then we're going to take a list of variable arguments. I'm going to call that args. And in order to actually use this VA list type, we need to include stdarg.h. And what this basically does is it hooks up this this ellipsis business for us here. So it'll allow us to actually say vprintf. Oops. Need a couple more things there. Include stdio. Oops. IO, not stdint. And I'm actually going to need string as well. Can't type today. Include. There we go. Oh, the benefits of live stream. Okay, so in our vprintf, we are going to take our prepend, and we're going to create a string. So we're going to create a string from that, add our message. We're also going to append a new line character at the end of that so that we don't have to pass in a new line every single time. And then we're going to pass it args, which is our VA list there. And so this will handle all of our console out logs that we need. I am missing a void type there. Okay, there we go. And what is this bleating about? Oh. Got my parentheses wrong there. Why is this complaining? Oh, because I need to pass a C string. Right. That's expecting a C string, not a string. So I'm using the sort of inline string here to quickly concatenate things. And then I need to cast that to a C string so that vprintf can actually recognize what the hell it is. Okay, so these functions here are all going to look almost identical, so I'm basically going to type this out once and then copy pasta to all the other ones. So the first thing we need to do is get our VA list, and I'm going to call this args. And then we need to call VA start and pass args and message. So it's basically going to say create the listing of these arguments after message, I believe is the way that works. And then we're going to call write log, passing to it our prepend, and this is where we're going to add trace, for example. And then our message, and then args, and then VA end pass args. And that's it. So it basically allows us a quick, convenient way to pass in a bunch of these, a bunch of different arguments here, and they automatically get formatted into the string without us having to do any work on the surface. And like I said before, I'm just going to copy pasta these things, all these methods, and the only thing I'll need to change is this trace to log. Let's keep that caps, warn, error, and fatal. And the fatal, I'm actually going to do one more thing. I'm going to include defines, and after it's spit it out to the console, I'm going to assert false. So this will automatically break our application. Identifier debug break is undefined. What? Okay. What is that saying that's undefined? Intrin be the include there. Very strange. I'm not really sure. Why is that doing that? Oh, this might be a problem up here somewhere. For one thing, there is one thing I forgot to do here. So I need to define this regen build lib in our project properties. Let's see, that is under trying to remember where that. Preprocessor def. That's what I'm looking for. I couldn't remember the name of the field. Okay. So we will actually, I probably ought to do this for the different platforms because I don't want to nuke these. So I'm going to put that there for debug, and release, I'm going to put it here because those actually are different. Okay. Need to figure out why this debug break is saying it's undefined. So let me see. This is being included, but it's not. I don't have any weirdness as far as assertions are enabled. Is the else enabled? I'm not sure. Why that debug break isn't working. See guys, this is the kind of stuff that of course will happen when you live stream. The kind of thing that I normally will cut out in my pre-recorded stuff, but this way you guys, I guess, will be able to see my process as far as actually figuring this out. So I'm going to look this up real quick. Yeah, intrinsic.h. Be let me just check comments real quick. Yes, definitely. That book is definitely a Bible for game engine devs. I absolutely agree. I've read through it probably 2 or 3 times. Have to save the video for later. I have university exams. Yeah, definitely. Definitely check it out later. This is great. Is this going to be a live stream series or just the first episode? I don't really know yet. It really depends on how this winds up going. Live streams, the only thing that I'm not really sure about as far as live streams go is they do take a while longer than the pre-recorded content. So it's going to kind of depend on what feedback I get. If you guys prefer the live stream where you can ask questions as the video continues, or if you guys prefer a more concise pre-edited approach to this. So I don't really mind doing it either way. I just know that the live stream does take a little bit longer to get through the video. So yeah, you guys tell me. All right, debug break. I see the problem. That's supposed to be lowercase. Okay. Now what is this deleting about here? Port assertion failure. Already defined in logger object. Multiply defined. Okay. This should be. Why is it saying multiply defined? Pragma once. Still going to delete that. Yeah, I didn't think it was that. Failure. Let me just make sure that I didn't get any other typos in here. when you switch back and forth between platforms and what are the different coding standards that exist in different platforms. Sometimes it's camel case, sometimes it's screaming snake case, sometimes it's nothing like this debug break and all lowercase. Sometimes it can mess you up, so just want to make sure. Let me try rebuilding this. Okay. I am getting a warning about the intermediate directory not containing a trailing slash. Let me fix that. I'm just going to fix the warnings to get them out of the way. So it's going to be under food directories. This is actually under the linker if I recall correctly. Additional library. Intermediate directory, there it is. Okay. Wants a slash at the end of that. Course inline, ignored, left, no variables declared. Okay. That is I suppose I should probably move this inside this if-def, because if assertions aren't enabled, it probably shouldn't be even adding this to the header. Try rebuilding this again. This is really strange because this is a function. I'm missing something here. Oh. Okay, I think I found it. That is not supposed to have a semicolon after it. Okay, now we're back in business. Sorry about that. That's something that's very easy to miss, so that's awesome. Okay, so let's see, where were we? So our logger is pretty much finished. So let me just test the logger. Include that. Include logger. And oh. Let's use log. That's fine. And we'll test this out with initializing regen engine. And let's also test the variable arguments. So I'm just going to pass 4 to that. And we should get this output with a 4. Just set a breakpoint there. And when we run it, we get a 4. So that is working correctly. So now we have everything that we need, at least for now, in place to actually start creating a window. So that is probably going to be the very next thing that I do. Now, a lot of times, what you'll actually find is a lot of tutorials will do all this stuff in line or in sort of the same file, and I like to split things up that I know are definitely going to be separate and should be separate ahead of time. So the way that I'm going to split this up, at least in the short term, is I'm going to create a platform class for the platform specific stuff like opening a window, and then I'm going to set up a Vulkan renderer to handle and house all the Vulkan code. And yes, all that Vulkan renderer code is going to wind up being in line, and we'll split that out later once everything's up and running. But I think for now, separating the platform layer and the Vulkan renderer layer are important things to do. So I'm going to go ahead and do that. Oops. So let me create a new item, and I'm going to call this platform. And namespace regen class platform, and platform is going to have a public constructor and a public destructor. Let's see. So the platform is really going to be ultimately responsible for our window. And since we're using GLFW, that's actually going to give us a GLFW window. But I don't want to include GLFW in the platform header because I don't want everything that includes the platform file to also have all that include information for GLFW. So I'm actually going to forward declare. Whoops. Visual Studio's IntelliSense is a little bit too overzealous sometimes. So I'm actually going to forward declare GLFW window. And I do know that that type is a struct. So the reason that I'm going to do that is so that I can store a private instance of it, which is going to be a GLFW window pointer. And I'm going to call that underscore window for now. And we want a quick convenience method here to return a pointer to that window. So we're going to call this get window and simply return window. And there's going to be a couple more things that we need to add. I think I'm going to add to this as we go because I don't necessarily want to add everything right now and then have to explain what I'm adding. So I am going to add a constant bool start game loop. And that is actually going to be what kicks off our main loop in the application. You know what? I wasn't going to do this initially, but I think I'm actually going to create an engine class too, because the engine class will encapsulate everything that the platform and the renderer need to do. And so I'm actually going to backtrack here for a second, and I'm going to add an engine class. So namespace regen class engine, and it's going to have public constructor. It's going to take a string. We're going to call this application name. I think that's all I'm going to take in for now. We need to forward declare a platform, so class platform, this time within the regen namespace, so that we can store a private pointer to our platform. Right, and then let's go ahead and create a void start, which will be the thing that we actually call from the main file to actually start the engine up. We may wind up not needing that later on, but for now, it makes the steps clear. Create the engine, then start it. And that will kick off the loop. Let's see. So the next thing we'll need to add will be, I'll make this public. Yeah, we'll need a void on loop, and this will take in an F32 delta time, which means that we need to import types, include types rather. Import, see, I'm still in TypeScript land. Okay, actually let's make that constant because we shouldn't be changing that. So what that's going to do is when the platform actually kicks off the loop, it will call the engines on loop, which will then handle any game specific updates. It'll handle any renderer updates that need to happen, and so forth. So it gives us sort of a central place to do that. I think, you know, I'm going to call this run instead of start. Not ruin, run. That should be it for right now. So let's go ahead. Actually, I need a destructor here too. We'll create the CPP file for this. Engine, oops. Include engine CPP, namespace, regen. And of course, we'll have to add the prefix to all of these. I suppose you don't have to necessarily do it this way. You could just declare all this stuff in the header file, but I don't like to do that because after you have a large code base, it makes things take quite a while to compile. Because you've got all this logic and includes and stuff all over the place, and it makes things really messy. So I'm not a fan of doing that typically. All right, so I also need to include platform.h. So during the creation of the engine, I will create a platform, which actually I'm going to need to pass this application name to the platform. Let me add that to the constructor. I don't think we have. Right. So I'll add that to the constructor so I can say platform equals new platform, application name. And then here I can say platform start game loop when we actually call run. And then the platform will call on loop. And actually, how's it going to know? So I need to actually pass platform an instance of the engine as well. So I'm going to add that for declare it first. Pass a pointer to the engine. And I'll store it. And then the engine. Wait a minute. I just added that to the wrong class. Good job. Needs to be added to the platform class. I knew something didn't look right. Okay. So platform now takes engine as the first argument, and then the application. Back in the engine, we'll pass it this, and then the application. Okay, and then from the platform perspective, let's go ahead and create the implementation of this. I'm going to item platform include form.h. I'm also going to include engine.h, namespace, regen, and again, add all the prefixes. This is one of the reasons I'm not going to be splitting everything out into classes right away. This is actually define our header. We don't need that at all. Okay, so engine. I don't think I have a private copy of the engine yet. So engine. Pointer engine. I move on. Let me just double check the chat here. Is it going to take me 100 hours to get this done? Well, to be honest, any engine takes hundreds of hours to write. So if you're looking for something that is done super quickly, just to get something on the screen, this is not that. Because I don't want to cut corners and then have to go back and change a whole bunch of stuff in order to support the things that should have been in there from the first place. So the way that I'm approaching this is I want to lay a lot of the groundwork first, and then just build on top of that instead of having to go back and redo it. So let's see. Yeah, it doesn't matter if it takes more than 100. It's a learning experience. Exactly. So yeah, this is not something that I'm planning on getting done only in a few videos. You know, this is going to be a full engine development from the ground up, and building an engine takes time. You know, there's a lot of aspects to building an engine, so I'm not looking to rush the process here. I'm looking to do it right. Okay, so platform, this is actually where we're going to be including all of our GLFW stuff. So I'm actually going to remove this stuff out of main and put that here. And in main, I'm going to include engine and create a new instance of it. So regen engine equals new engine, regen engine, and I will just pass it regen for now for the application name. Likely to be changing. And then we'll pass engine, call engine run. And then the only other thing we'll have to do here is once run completes, we'll delete engine. So this right here is the entirety of our main entry point. There's nothing else that's going to be here aside from this. In fact, I'm going to move this log into the engine itself as well. I probably also don't, but I'll leave that there for now. Okay, so let me just put the log there and include logger. Cool. All right. So now that we have our platform and we have our engine all created, yes. Okay. So we should be good to actually start adding our GLFW code. So first thing that we're going to want to add to this is we're going to want to define GLFW include Vulkan. We're not going to need this right away, but when we go to stand up some of the other methods, such as getting a window surface and so forth, we're going to need that, and I don't want to forget it. I'm going to go ahead and include Vulkan as well. Because we are going to need that in a couple places there. Okay. So let's also add logger. And we'll just output some trace information right now. We'll probably add to that later to make it more useful, but so GLFW. The first thing we need to call is GLFW init. And this performs a bunch of initialization for GLFW under the hood. If you don't call this, the window creation will fail. The next thing we need to do is call GLFW window hint. And for this, we need GLFW client API, which it's telling GLFW what window hint we're passing, and then the value of that is going to be GLFW no API. And the reason for that is because GLFW was originally written for OpenGL, but we're not using OpenGL at the moment. I may add an additional OpenGL renderer at some point to this, and if I do, in that case, then we'll need to pass that information. But for now, since we're using Vulkan, we don't actually need to pass it any sort of API information. In fact, this GLFW include Vulkan kind of handles some of that for us, but more on that later. So let's create the window. So window equals GLFW create window, and we need a width and a height. So I'm gonna use 10. Actually, I'm gonna use 720p for now. So 1280 by 720. The title is going to be the application name. And then monitor is null pointer and share is null pointer. Because those are monitor we don't really need, and share is like a OpenGL thing, so I'm not gonna go into those for now. One more thing, GLFW create. No, it's not create. Is it set? GLFW user. What is it? GLFW set window. There it is. GLFW set window user pointer. And this just allows us to set some sort of user data, which we can then later query from the window. And I'm just going to actually include this as that. So what window we're going to be attaching to is underscore window, and then we're just going to attach this to it. So that if we need that somewhere else, we can always pull it. I don't think we're going to need that, but better to have it than not. Okay. We'll also want to make sure in our destructor that if a window exists, that we destroy it. So GLFW destroy window. Cool. And then call GLFW terminate. So this is sort of the other end of this GLFW init. So everything that happens under here is undone under here. Okay, start game loop. So this is what is actually going to kick off our main rendering loop. So the first thing that we need to do is create a while loop. And we want to say while GLFW window should close, or while it should not close. So we want the negative of that. Pass window. So it's basically saying while this application window should not close, we need to keep looping. And we need to pull for events. And this is any sort of any sort of input that happens, we want to pull for that. And eventually in here, we're going to be filling things out, such as keyboard input, mouse input, closing the window, things of that nature. But for now, we're just going to simply call engine on loop. And we don't have a delta time yet. I'll sort that out later. For now, I'm just going to pass 0. So the delta time is the amount of time in milliseconds that, or well, I could go either in milliseconds or seconds since the last frame. But in this case, I'm just going to pass 0, and we'll deal with that later. And then we'll return true. And there may be circumstances later on where maybe some of this stuff fails and we might want to return false, and then that's sort of an error condition. I don't know if we're actually going to wind up using that stuff, so right now I'm just going to return true and call it a day. Let's see. That, I believe, should be everything that we need. Unresolved. Oh, I forgot to set up part of the linker stuff. So under input, I need to add a couple things. Forgot this step. So in the linker input, we need to add GLFW.lib and Vulkan1.lib. I think that's what it is, Vulkan-1.lib. Apply, okay, build. GLFW, oh, I think it's GLFW3 lib actually. Cool, run that. And now we get both our console window and our GLFW window. And this is basically, at least for right now, that's everything that we're going to be doing on the platform layer. So that's good. That all works. Awesome. So let me just check the chat. Okay, cool. All right, so I'm going to go ahead and move on. The next thing that I want to tackle is creating the renderer. And this is the bit that we're probably not going to finish today. I likely am not going to get too far into this, but I at least want to get some of the groundwork out of the way so that we don't have to completely start from scratch on the renderer in the next video. Because I want to get make sure all the linking is right and get that kind of stuff out of the way. So I'm going to create a new file. I'm going to call this Vulkan Renderer. This one is going to include Vulkan. And namespace regen. Okay, and then class Vulkan Renderer. And of course, we're going to have a public constructor and a public destructor. And the renderer is going to need access to the platform, so we need to forward declare that. That will be more obvious later as to why that is. Learn how to type. Can't type today for some reason. I'm also going to store off that platform, just in case we need it later. Okay. So the way that Vulkan works is it's a very explicit API. And just to give you guys an idea of how explicit that API is, I actually have the Vulkan spec open here. And this version actually has, this version here is actually split up between different files. But just to give you an idea, this is the table of contents, and it's that long. So this is a gigantic API. We're not going to be using the whole API, at least not right off the bat. But I would highly suggest, if you guys are serious about learning Vulkan and really understanding how it works under the hood, to read through this spec from top to bottom. There's lots of resources online about this as well. If you guys are new to graphics programming, you're probably going to want to brush up on some of those things first. Another book that I would recommend there is one that I've picked up. It's this one. Let me just make sure that you guys can see it. So it's Real-Time Rendering. This is the 4th edition. And this explains how GPUs work and graphics pipelines and all that kind of stuff. And you really probably ought to have a solid foundation of the way all that stuff works. So I'm going to be building through this sort of as I'm learning the Vulkan spec, because I've been working with Vulkan now for a couple of months, but you know, I'm by no means a Vulkan expert. I don't know that many people actually are, but yeah. So we'll be referring back to the spec a lot, which is fine. But yeah, I just wanted to sort of bring that up because we are going to be using this guy a lot. So with that out of the way, let's go ahead and start setting things up. So the first thing that we're going to need to create is what's called an instance. And a Vulkan instance is basically the implementation of Vulkan on your system. So an instance is basically the entirety of Vulkan that's also powered by your graphics drivers on your particular system. So it's not the GPU, it's not any of that. It's the actual implementation. Because Vulkan, of course, is just an API. You've got to implement that somewhere. And then what you do from there is you create an instance, and then you create, I should say you choose a physical device. And what the physical device is it's a representation of your physical GPU that you have in your system. Some systems have more than one, particularly like if you're on a laptop and you're using like an NVIDIA Optimus that's also got an Intel GPU on it, or it's got, you know, a dedicated GPU. You'll note that there will be more than one. And then after that is created, and that's a whole process in and of itself. After you've chosen one, rather, then you need to create a logical device. And a logical device is basically your application's view of the graphics device. So the logical device is the one that's actually used to make all the other calls in Vulkan, pretty much. So once we have the groundwork laid and we have our logical device stood up, everything going forward pretty much uses that. So that is the point I'm going to try to get to today, is the logical device. And if we get beyond that, great, but if not, so be it. So let's see. So we have Vulkan Renderer. Let's go ahead and get our CPP. And we'll include Vulkan Renderer and namespace this. Okay. Now, as I mentioned before, for now, all of our Vulkan logic is actually going to live in this file. So this file is going to wind up getting pretty gigantic towards the end, but that's okay. We will eventually go back into this and split things out. All right. So back in the renderer, we're going to want to create a few other things that we want to store privately. So we want to store our VK instance. So that's the instance that I was talking about. That's the Vulkan instance. And then we want a VK physical device, which I'll just call physical device. And then a VK device, which is our logical device. I'm just going to call this device. But this is the device that we're going to be using for 90% of our calls throughout Vulkan. Okay, so one more thing that we're going to want to create actually right after we create the instance is a vk debug utils messenger, I think it was messenger ext. And what that's going to do is provide us a way to output some debug data to the console. So another thing that I should probably explain about Vulkan is it's a very lean and mean light API. And as such, it has basically no error checking on its own. And so when you're developing an application in Vulkan, you need to basically put in all those debug hooks yourself or use what's called validation layers. And validation layers will actually run additional code to ensure that you've performed the steps correctly and that all the data is as it should be before it actually tries to execute. And if anything is wrong, then it'll spit that out to the console. This debug messenger is one of the ways that that is actually written out to the console. So we're definitely going to want one of those because until you're actually ready to release an application, you're really going to want those validation layers in place. Otherwise, you won't know how things are broken. Okay. So let me just double check chat again before I jump into this. Yes, I grew my hair out. Thanks. Yeah, my goal with this actually is to I'm going to grow it out long enough so that I can cut it off and donate it to cancer patients, because I've lost several close people in my life to cancer, and one of the things that they unfortunately always have to deal with is hair loss. And so I figure while I've got decent hair and I can grow it out, I'll do that. So I've done it twice before. This will be my third time doing it. So it'll probably be a year or so before I actually wind up cutting it off. But yeah, that's why that is. Okay, let's see. So next one, beard too. Yes. You thought I was JavaX9. Yeah, I don't have the British accent though. I could imitate one poorly, but I don't think anybody really wants me to do that, so I'm not gonna. Great books to read. Real-time rendering, 4th edition. Yep, that's a great book. Yeah, okay, those are the ones I mentioned. Yeah. Donating is epic, wonderful. Yeah, it's something I've done a couple of times, so it's one way I can at least help them, you know. Aren't there also C++ bindings for Vulkan? Yes, there are. So I decided to go with the C bindings instead of the C++ bindings for a couple of reasons. The C++ bindings, the header file is a lot heavier for that, so it increases compilation time. It also, up until at least very recently, had a number of bugs with it, whereas the C API really didn't. I don't know if that's necessarily true anymore, but I don't really want to find out the hard way. And then the other reason is because most of the documentation out there and tutorials or even the spec itself all references the C API. So to me, the C API just makes more sense. You're more than welcome to switch to the C++ API if you want. But for this project, I'm not going to do that. Cool. So let's move on. So the first thing we need to do is obviously save off our platform. We need to include platform because we're going to be using that. I'm going to go ahead and include logger as well because I know I'm going to need that. And I'm going to include, actually, in Vulkan Renderer H, I'm going to, Vulkan Renderer H, I'm going to include types and include, actually I'm not going to do defines there. I'll just do types because I know I'm going to need those types. So I'll add include defines. Okay, now that all that's out of the way, suppose I had to put something in here similar to what I did for the platform layer. Grab this real quick. Okay. And now comes the fun part. Now is when we start filling out all the Vulkan stuff. So the very first thing that we want to do, like I mentioned before, is create an instance. But creating an instance requires some other things to be done first. So if I create a VK instance create info, I'll call it. One of the things that we will look at is you'll see this pattern over and over and over again in Vulkan. So anytime you create something or allocate something, depending on what type of resource it is you're dealing with, you're going to be passing it one of these create info structs. And these structs, at a minimum, always define what the structure type is. So there's a very large enumeration for structures. It has all these different types in it. So we have to tell Vulkan what type of struct we're passing. And the reason for this is to make it extensible. So these are all the structure types that are available in Vulkan, at least Vulkan 1.2. So in this case, we have a create info where we need the type. pnext, I'm not going to go into that right now. We're not using that. That's going to be set to a null pointer. Any sort of creation flags. Most of this stuff actually we're not going to be using right now. The one thing that we are going to be using is this application info. And this application info will actually tell us a little bit more about the application itself. So we'll actually need to create one of these first and then pass that to our instance create info. So VK application info, and we'll just call this app info. And I like to shorthand the S type. The S type is always the very first thing that gets added. Look here, it's always the first property, right? So the way that I like to do this is when I create the structure, I like to initialize everything to 0 except for the S type. So it's all in one line. So VK structure type application info. And so what this does is it automatically fills out that S type for us all in one line, so I don't have to take another line for that. Because as you'll see with some of these structures, some of them take quite a few lines. I suppose you could create them all this way, but you have to sort of do them inline if you do that. I'm not really a huge fan of that. I like to just 0 initialize everything and then fill in the properties that I need. So the first thing we'll want is the API version. And for that, we're going to be using VK API version 1.2. Now, if you have a GPU that doesn't support this, by chance, you could use 1.0 or 1.1, but I would suggest using the latest greatest if you. I'm not going to be covering any of those old versions here. I'm just going to be using 1.2. So the next thing we're going to want is the P application name, which in this case, I'm just going to hard code that to regen. Because that is, it doesn't really mean anything. It just tells Vulkan a little bit about our application. Some of this stuff is kind of reserved for future use, and Vulkan's, what's the term I want to use? Optimization for particular engines or applications, because some of those things like Unreal and in Unity will have specific optimizations that are made within Vulkan or within the Vulkan drivers, where they'll actually take that string and invoke those things. But in our case, that's obviously not going to be the case. But just in case this engine ever blows up, it's there. Okay, so the next thing is going to be the application version. And in this case, we want a VK make version macro. And here we're just going to pass 100 app info. So let's see, the next one is going to be the P engine name. So this would be Unreal, for example, if we were writing against Unreal. But in this case, we're just going to pass no engine. Doesn't really matter what that is, but no engine shouldn't ever be used, I don't think. So we should be safe there. And then engine version. So vk make version, and we'll pass 1.0.0 again. Cool. And now let me just set up this instance create info, similar to how we did before. So vk structure type instance create info. And we will set application info to the address of app info. Okay, cool. So now that we have our create info, there's a couple more things that we're going to want to do. So you've heard me mention extensions a couple of times. There are extensions to Vulkan that support things that aren't included in the core library. The easiest example of one of those things would be the OS-specific surface creation extension. So there's one for Win32, there'll be another for Linux, and so on. And then there's also various extensions that could be required by the platform as well, which thankfully GLFW provides a lot of that for us. And then there are also debug extensions that we might want to load that will power our debugger that we're going to write later. So before we can move on, we need to add something to our platform to obtain those platform-specific extensions that I referenced. So in this case, I think the easiest way to do it, because this is more or less targeted at a C API, is do it sort of C style. So I'm going to create void get required extensions, and this is going to create a it's going to take rather a pointer to a 32-bit unsigned integer, and that's going to be extension count, and then it's also going to take a triple pointer to a constant character. So and that's going to be extension names. So just to explain the reason for this is we're basically going to be creating an array of constant character pointers. And then we need a pointer to that array so that we can actually address that within this function instead of having to pass it back. So it's a pointer to an array of pointers, basically. I think I got that right. Anyway, let's crack on with making this method. So just paste that in there, put our prefix. And this method is actually going to be pretty straightforward. We're just going to dereference extension names. And we're going to set that equal to GLFW get required instance extensions. And we are going to pass in extension count. So it will set that that integer for us. So it'll basically tell us how many extensions we have and then what all the names for that extension are. That, I believe, is it for right now. We'll have to come back to this, add a couple more things afterwards, but for right now, that should be sufficient. So let's see. I guess the next thing that we'll want to do is we want to create a constant character array, or an array of constant character pointers. And I'm just going to say platform extensions equals no pointer. It'll wind up getting updated anyways. And then I'll create a U32 for the extension. I'll just call it count, whatever, and set that to 0. And then I'll call platform. Actually, let me use the class member of that. So platform, get required extensions, and then I'll pass reference to count, and the same for PFE. So that will set these two. And then what I'll want to do is, just for the sake of making this a little bit easier, I'm going to include vector. And we'll create an std vector of const-char pointers. And then we'll call this platform extensions. And then what we'll do is we'll loop actually through this array and push those back. And the reason for this is because we'll actually need to push one back dynamically on top of this. So we can't just use the array as is. So rather than messing with alloc and realloc and all that crap, I'm just going to do it this way because it seems a little bit easier. So u32 I equals 0, I less than count plus I, and then platform extensions push back PFE I. Okay. And then after that, we also need to push back platform extensions. And we need something vk ext debug. What was it? Debug utils, I believe. Extension name. There we go. So this is actually a macro that contains the extension name for the debugger that we're going to need to load in a bit. So we want to add that to the required platform extensions as well. All right, and now we can actually add this information to our instance create info. So we can say enabled extension count, cast this to a u32, and say platform extensions.size. I need to cast that to a u32 because that is what this is expecting. So this returns a 64-bit integer. We need 64-bit unsigned integer rather. So we just need to make that quick cast. And then we need the actual array of extension names, which is just going to simply be platform extensions data. Cool. So that covers it for the extensions. Now we need to load the other thing that I mentioned before, which is our validation layers. The validation layers are, again, what's going to help us debug. So in this case, we actually only need one, but I'm going to create a vector of them anyways because we might want to add to this later. So I'm going to call this required validation layers, and I'll set that to include one string, which is going to be vk underscore layer underscore chronos underscore lowercase validation. Make sure you spell it right too. So this is a validation layer that is given to us by the Vulkan SDK, and so it's not something that is typically included with your typical Vulkan runtime. So there will be lots more validation layers that we're going to be using, but for right now, that one is the most important. So that's the only one we're going to actually include. Okay, so the next thing we need to do, now that we have our required validation layer, is we actually need to get the layers that are available to us. So this is actually going to follow another pattern that you're going to see quite often throughout Vulkan, is where we actually have to call things twice. So first off, let me just store available layer count. So we need to call vk enumerate instance layer properties, and we need to pass the address of available layer count. And then you'll also see that it takes a pointer for an array of vk layer properties, but this time we have to pass no pointer. So the way that this works is the first time that you call this, whenever you're enumerating anything, is you pass it a reference to the layer count, and you pass null for the actual data, and that returns the layer count. And then you have to call it again to actually retrieve the data. And I suppose they do this so that you can actually allocate the proper resources on the application side before you actually call it again and try and fill it full of data. I don't know whether I love or hate this, to be honest. It makes things a little bit more verbose than perhaps they need to be, but I mean, it's a little safer, I suppose. So we'll need to create a std vector of vk layer properties, and we'll call this available layers. And we will create that with a capacity of available layer count. And then when we actually call vk, actually, you know what? I'm gonna take a copy of this and just paste it, because it literally is the same thing. The only difference is now you pass a pointer to the, or I should say, an array. So in this case, oops, available layers dot data. So we're specifying here how big this vector is, and then we are directly filling in the data by passing it the data pointer, which is a pointer to the underlying array type that the vector uses. Now, one thing that I do want to point out is that there are a lot of tutorials out there that'll sort of just leave it this way. But if we hover over this, we'll note that there's actually a vk result that is returned from this that can indicate success or failure. And we don't necessarily want to ignore that. We always want to be checking to ensure that all the operations that return one of those vk results are always successful. So rather than doing an if call around every single one of these to determine if it's successful, I'm actually going to create a quick utility for this. So I'm going to add a new item. I'm going to call this, give me a header. It's going to be called Vulkan, oops, Vulkan utils. And it's simply going to define, let's call this vk check, and then we'll pass in expression. And it's basically going to do something very similar to our assert, where we basically, in fact, I'm going to use asserts for this, actually. Include defines, and I'm going to assert that expression equals vk success. And of course, to have vk success, I also need to include Vulkan. Get a slash there. Okay, so we're actually going to use our already existing assert. And we're just going to make sure that whatever is passed into this returns successful. And if it doesn't, we're going to assert and kill the application. In production, this may not always be ideal. You might want to actually handle this For example, when we are creating resources of some sort and we try to create a unsupported type, we might want to try creating another type as a fallback. But for now, I'm just going to handle it this way. So at the top here, we're going to include Vulkan utils. And then we can wrap this in a VK check. And same thing here. Cool. So the next thing that we need to do is we need to take this available layers list and compare it against our required validation layers list. And make sure that all the validation layers that we're actually requiring are available, because if they're not, we shouldn't be running at all. We should immediately abort. So that all required layers are available. So we'll store a bool for success, and we'll default that to true. And then if we find something that's missing, we'll set it to false. And then throw an error for that later. We may not actually wind up needing that, but we'll come back to it. So 32i equals 0. I is less than required validation layers dot size plus I. And actually, this should be cast to a u32. Okay. So we'll need to track if we found it. By default, it's not found. And then loop through, very similarly, the available layers. So j is less than available layer count plus I. Oop. Plus j, not plus I. That would have been a bug. Probably name those a little bit better, to be honest. And then we'll do a string comparison. So string comparison between required validation layers I and available layers j dot layer name. And we'll want to make sure that they're 0, right? So if we have a match there, then we want to say found equals true. And we want to break the loop because we don't need to keep searching, right? So we found a match in our available layers to our required. Let's see. So if we loop through all of that and we've not found it, then success equals false. We're actually going to logger dot. Let's fatal this. Oops. Required validation layer is missing. And pass it required validation layers I. Right. And then break, which actually isn't going to be needed because it's going to crash the application, but so like I said, we may not need this success. I'm going to keep it for now, just because there may be a way that we want to fall back and handle it and maybe do something else. Whatever, I'll come back to it. So our instance create info now needs to be updated. So we have our enabled layer count, which is going to be cast to a u32. Our required validation layers dot size, and our instance create info dot pp enable layer names is going to be required validation layers dot data. Okay, so that should be everything that we actually need to go ahead and stand up our instance. What is this about? Oh, just uninitialized. That's fine. We'll fill that later. Okay, so next we need to call vk create instance. And this is what is actually going to create our instance. So we're going to pass it our instance create info, or at least the address of that. Next, it expects a p allocator, and this is a custom allocator if you want to use one, or you can just say use the default allocator by passing no pointer, which is what we're going to be doing. I may switch to using a custom allocator at some point, but for now, I'm not going to bother with it. It's not really needed. And then, of course, we need to pass the address of our instance. And we'll need to add the vk check surrounding this to make sure that that is created. So here is where the instance is actually finally created. And the instance has to be created before we can do anything else. So if that fails, we're dead in the water, basically. So let's go ahead and build this. And include types. I need to fix that warning at some point, but let's create a breakpoint right here and run this. Okay, so if we take a look at our, oh, that's interesting. It didn't actually hit the breakpoint. Oh, I think I actually forgot to create the renderer. Yep, okay. Missed a step. All right, so we actually need to forward declare a class Vulkan Renderer so that we can store that there. And then really quickly, in engine, we want to include Vulkan Renderer, and it needs the platform, which we can pass along. Run it. There we go. Okay, so if we look at our create info, we can now see that everything is filled out as it should be. We have our application info. That all looks good. Layer names are in there. Our extension counts are in there. Cool. So we should be good to go. Let's go ahead and step over this. And it looks like it created our instance successfully. Yes, it did. Without any errors. So that is our Vulkan instance. Cool. So we actually have some Vulkan logic in here up and running. Granted, we're a long way off from writing anything to the screen, but this is the first important step. Just check the chat here. Okay. Like this live stream format, I'd recommend keeping this series a live stream, however you want to do this. Okay, yeah, I mean, I could do that. I love you too. I need more series on game development plus within gameplay editor and engine. Okay, so yeah, we're actually going to be getting to all these things. So one of the things that I want to create as part of this series is an in-game editor, an in-game level editor. Obviously, we have to get a renderer up and running first. So that's kind of a ways off, but yes, we will be getting there. Yeah, okay. So let's see. We're already at 2 hours. I don't know. What do you guys think? sort of on the fence as to whether or not to go into device creation or not. Would you guys like to see the device creation now, or perhaps in a separate stream? Because I know this is already kind of a long stream as it is. Any GUI library preference that you might be using, like IMGUI? I could use that. I know that library was primarily targeted at OpenGL, and it's been around for quite a while. I might do that, but what I'm leaning more towards is actually writing a custom UI system. And the only reason for that is because I want to build as much of this from scratch as possible. Now, granted, I sort of cheated a little bit with GLFW, but I'm probably going to wind up ripping out GLFW at some point in the future. I just didn't necessarily want to do all that setup code on the stream just yet. So, will this be an engine with an editor and in-game? Yeah, so it is going to be, there'll be a couple of things that obviously you won't be able to edit in-game. Things like shaders and whatnot when we get to that point. Will probably be... I'll try to make as much of it in-game as possible, but there's some of that stuff that you really can't do in-game. Yeah, I mean, it's a bit premature, I guess, to sort of discuss that at this point, because I don't actually have this engine like pre-written ahead of time or anything like that. Like we're actually writing all of this sort of on the fly. So I'll make as much of it in-game as I can. Custom GUI, that would be fantastic. Yeah, it is going to be a lot of work to do that, but I think it'll be worth it because exploring the way that GUIs work under the hood, I think, is a valuable thing, and I think it's something that often gets overlooked. Level editor as well as a code editor, visual scripting. So visual scripting, I've written a couple of those before, just lightweight ones. And I have mixed feelings about them. I think that they're cool for really lightweight stuff or simple stuff, but I think that they tend to get overused, and they can tend to be a little bit heavy in the logic that they generate, depending on how that's done. So I may or may not do a visual scripting language, but there will be various aspects of it that are sort of configurable visually, like state machines, for example, and that kind of thing. I don't know yet on the visual scripting bit. Code editor, I'm probably not going to make a code editor for this. And the reason for that is I think the way that I'm actually going to set this up is somewhat similar to the way that Unreal does. So right now, everything is in one library, and eventually I'm going to actually split this into two libraries, so the game will actually be a separate library. And the way that I want to have this work, if I can figure out the best way to do it, is to get the game library to hot reload while the engine's running, so that basically you can code all your game logic in C++, but then be able to build that while the engine's running and hot reload it. So that's kind of my goal. I've not built one of those before, so that likely is going to be a challenge. But yeah, that's kind of my goal with it. Let me see. Worth 1 million views. I appreciate that. I mean, how to code everything from scratch. Lots of years of practice, to be honest. And I don't code everything from scratch. There are some bits of it that I have to look up. I think Einstein said something along the lines of never memorize anything that you can look up. So that's one of the reasons that I refer back to the Vulkan spec a lot, is because instead of trying to memorize off the top of my head how all this stuff works, it's much easier to just reference something, and then I can actually memorize the things that matter. You know, as far as like design principles and how to hook things together in a decoupled way, things like that. Programmers, more than memorizing, they refer docs. Yeah, I mean, I think what you're saying there is that most programmers do refer to docs instead of memorizing things, and that's true for the most part. I mean, there will be certain things that you wind up memorizing naturally, like these patterns that I keep talking about, like, you know, getting the count and then getting the data. So a lot of those things tend to come naturally after you've been working with something for a while, but yeah, that's, I guess that's my answer there. I hope I answered your questions. Okay. I think what I'm going to do is I'm going to go ahead and create the debug, the renderer debugger that I've been talking about. And then we'll see how we're doing for time. And depending on that, I may move on to devices, or I may leave that to the next video. So let's go ahead and create the renderer debugger. I believe I've already created something in here to actually hold it. So we've already imported the extension that we need to support this. So that was the reason I did this up here, so I didn't have to go back and do it. So it should just be a matter of creating the actual debugger itself and standing that up. So to create the debugger, we need a vk debug utils messenger create info ext, that one. So debug create info, and obviously I'll set its S type. So vk structure type debug utils messenger create info ext. There it is. Some of those get kind of long, so the pattern for this though is after this vk structure type, if you look at this, every word here that's underscored, it actually matches up with this type here. We have debug utils messenger create info ext. Debug utils messenger create info ext. They did that on purpose to make it a little easier to handle. Thank God, because there's tons of them. So debug create info, message severity. So this is where we're going to set the severity levels of the things that we actually want to log. So this is going to be, again, a couple of enumeration values ordered together, and they're kind of long. So vk debug utils message severity error bit. So we want errors, and I'm just going to copy this. And so to errors we want to or, and we want, I think it's warning. Yeah. And then we also want, for now, I think it was info. Yeah, okay. So basically this is going to output a lot of stuff. We're probably going to trim this down later as to what actually gets output. But basically if anything comes across that's an error, a warning, or just general information, it's going to be written out to the console. There is also a verbose option for this too, I believe. I'm not going to be including that because it's way too noisy. So debug create info. The next one is going to be message type. And these are the types of messages that we want to accept. So vk debug utils message type. And then what we're going to want to use is all three of these. So we're going to have general, performance, and validation. So we'll get general, and we want performance. And then we'll also want validation. And the validation one is probably, honestly, the most important out of all of them, because that is actually what's going to spit out our validation errors if they actually occur, so we can figure out what's going on. So debug, create info. So the next thing we need to create a callback that meets the criteria of this type. So if we take a look at this, this is a pointer function that takes in message severity, types, callback data. Wait a minute, I think this is the actual... Right, MP user data. Let's see. I think that's the actual call. Right. That's this. Okay, so we're actually going to take a copy of this, because this is the exact signature that we need to use and hook back into this guy. And there's no need to actually declare this in the header. I am again going to just do this. I'll make this private by only including it in the CPP, because the CPP is actually the only thing that needs to know about this. So I want to include static and then VK API attribute, which basically just wires up some OS specific stuff to determine what stream all this stuff gets written out to, which is just the STD stream that we use for pretty much everything else. And then I will paste this. We have vkbool32, and I'm actually going to remove this bit because we don't actually need the pointer function information. We just need vk API call. Oops. And then we'll call this debug callback. And then there we are. Okay, and the reason I copied this is because I really didn't feel like typing all that out. So in a lot of cases, you can actually just go in right to the definition of it and copy this stuff verbatim versus going in there and typing it out the hard way. It's up to you which way you want to handle this, but in my case, I don't always want to type everything out manually. So, all right, so the next thing we're going to do is we're going to actually switch on the message severity. And the default case, we're actually going to tack onto the default case. And we're going to use vk debug utils message severity. Use error as the default. Yeah, we'll use error as the default. I may wind up switching that later, but for now, error is fine. And so, but what we're going to do short term is we're going to, for each one of these different levels, we're going to call a different logger function. And this is another way that we can sort of filter out these logs as we go. So in this case, I'm going to call logger.error and pass it p callback data, p message. And p message is a string. And so it lines up with our error nicely. And all the other cases are going to look almost exactly like this. They're just going to switch on the severity. So this one will be warning. This one will be, I think it was info. And even though we're not using it, I'm going to fill out verbose. And instead of error here, I'm going to use warn. Here, I will use info. I'll use log for that one. And then verbose, I'll use trace. And then we actually look up in the Vulkan spec. So this is the spec for the debugging. And actually, if we my window. If we look down here, debug messengers in here, where was it? Return codes. You know what? Let me actually just copy the. I think that should. Here we go. So it returns a VK bool 32. So it says here that it must not call destroy debug messenger. So obviously the callback can't destroy itself, which if you think about it, really makes a lot of sense. It returns a VK bool 32. The application should always return VK false. VK true is reserved for use in layer development. So I just kind of wanted to explain really quickly why I'm going to always be returning VK false. And there you go. So we can now just grab this, go back down to the bottom, and now our pointer function user callback is hooked to debug callback. I guess the next thing we'll want to do is I want to set the p user data to this, just in case for some reason we need it. And that's it for the create info. The next bit is a little bit more involved. So since this is an extension, it's not actually loaded for us automatically. We actually have to load this. And so to do that, we need to get a function pointer. So a lot of these function pointer types are already defined for us. We just need to actually load the function pointer itself. So we need a pfn vk create debug utils messenger extension. We'll just call that func for now, and we'll set it equal to. We need to copy this because we need to cast to it, and we need to call vk get instance proc address. And what this is doing is it dynamically dynamically loads the address of a procedure or a function, if you will. And in this case, it needs a copy of the instance, so we'll give it that. And then it takes a string of the procedure that we want to load, which happens to be almost exactly the same thing, minus the pfn. So we can paste that again and just reuse it. And then we'll want to assert message here. And we'll want to assert that function exists. And if it does not, we'll need to abort the application and say fail to create debug messenger. Because honestly, if we don't have this, we're up the creek without a paddle, because there is a lot of things that we're not actually going to be able to debug without this working properly. So the next thing we'll need to do is call function, pass it instance, because that's the first thing it requires. Then we'll need to pass it the create info, and it's wanting a pointer to that, so we'll pass the address, which is debug create info. Allocator is no pointer, just like always, and the p messenger is actually going to be a reference to underscore debug messenger. Cool. So that is what is required to actually create our debug messenger. Now, there's a couple more things that I want to do real quick before we run this, before we forget, and that's we actually need to destroy some of this stuff that we're creating. And we need to destroy these things in the inverse order of that which they're created. So the last thing to be destroyed is going to be the instance, so we need to call vk destroy instance, and we'll pass it instance, and p allocator is no pointer. And And then we should probably check to see if debug messenger exists, and then if it exists, we'll need to destroy this. But again, like the creation function, we don't actually have a destroy function loaded, so we're actually going to have to load that dynamically and call it. And so I believe, let me just check my notes here. Yeah, it's pretty much, it's almost exactly the same thing. So I'm actually just going to, I'm going to copy this guy, and instead of create, I want destroy. Should be, yeah, everything else should be the same. So I'm actually just going to copy all of this and paste it here, and just replace these guys. Make sure to get rid of that. I don't know if I really need to assert this destruction. I think the OS will clean it up afterwards. I'm actually going to comment that out for now. And then the function actually does still require the instance, requires the messenger and the allocator. So delete these two. It needs the messenger and the allocator's last, which is null pointer. And that should be it. Okay, let's build this. And I'm actually going to, break it on the destruction. Okay, so we actually can't, we can't see anything here yet because we're not actually doing anything that requires validation or that's failing validation. So yeah, I think this is probably actually where I'm going to stop. Just occurred to me that you guys actually couldn't see the window that I had here. Sorry about that. It pops up on the other screen for some reason. So we actually don't see anything here that that is output by this debugger yet, but we will once we go to create the device. So yeah, I think I'm probably going to end it here. Let me just read back through the comments. So I'm not sure. Are you asking if I'm going to make an engine like on the scale of Unreal or Unity? The answer there is quite honestly a no. Simply because those engines already exist. I wouldn't really want to recreate them. That'd be a bit pointless. So what I'm going for here is a lightweight engine that maybe doesn't have all the features that Unreal and Unity do, but as a result, it's a simpler API to use, and it leaves a lot more stuff up to the actual consumer of the API to implement some of that stuff. So I'm going to say no, because I am just one person, and if I tried to create something the size of Unreal, I'd be here 10 years trying to do it. Next, best book recommendations. So yeah, the two books that I recommended before, the game engine architecture and the real-time rendering, are good. I also have this book, which is the Vulkan cookbook. This is actually a pretty good book. I bought this when Vulkan first came out. So this is actually based off of Vulkan 1.0. I'm not sure if they have a new edition of that yet, but that was a pretty good book as well. I hope that helps. Let's see. So yeah, actually, I do have a lot of resources on the Discord channel. So I've actually created, let me pull it up here. So I've actually created a Vulkan channel here, and I've started pasting links into some resources for Vulkan. So links to the spec, the SDK, render doc that we'll be using at some point to actually debug some of this stuff. A good post here on how to learn Vulkan, because Vulkan is a massive undertaking to learn, and you probably ought to do some reading on learning how to learn it. Honestly, it is very, it's very important, I think. And this article does a pretty good job of explaining that. Also, this a trip through the graphics pipeline. It is old at this point, but everything that's mentioned in it is still highly relevant. So I would highly recommend that one. And then some of these other things are, let's see, this Vulkan in 30 minutes. Probably won't be ready for that until you at least understand graphics APIs in general. Vulkan tutorial is very good. There's also, I thought I had in here, I could have swore I had the Intel one in here, but I guess I don't. I'll have to add it. There's also a tutorial by Intel that is pretty good, although it's a little bit dated now. I think it's still targeting 1.0, but a lot of the concepts are still there. This Vulkan examples by Sasha Willems. This is, I plan on using this a lot, honestly, because he's got a lot of really good examples in there on how to do different things in Vulkan. But I wouldn't recommend even touching that until you have a basic understanding of how Vulkan works at a high level. Awesome Vulkan is basically linked to a bunch of Vulkan resources, similar to what I have here, but it's a much more exhaustive list. Vulkan synchronization primer. This is all about memory synchronization, which we haven't touched here. But when we get to that point, I'll be referring to this resource again. And then, of course, the Vulkan subreddit. And, of course, you know, I like chatting in Discord as well. I don't typically have too much time to be answering tons of questions in Discord, so most of the time, most questions that you're going to have, honestly, are searchable or Googleable. That's not a word, I guess, but whatever. Most of the answers to this stuff can be found online. You just have to know where to look. So anyway, guys, I think I'm going to go ahead and end this stream here, because it's been a couple of hours, I think. Let me see. Yeah, it's been 2.5 hours. So I think I'm going to go ahead and end this here, and we'll pick this up another time. Let me know what you guys think. I know a couple of you have given me comments on this. Let me know what you guys think about the live stream model versus the sort of pre-recorded model. It is going to take a lot more time, I think, to go through all of the content on the live stream model, which is good for people that are following along with, but might not be so good for people that want to check it out later. So I'm a little torn there. So let me know what you guys think. Leave that in the comments. If you guys aren't subscribed, please feel free to do so, because I'm going to be releasing a lot more content having to do with Vulkan, as well as the other series that I have going. So thank you guys, all of you, for showing up. I really appreciate you guys sticking with it. And yeah, cool. I'll see you guys next time.